ICMP protocol. ICMP stands for Internet Control Message Protocol. As mentioned earlier, this is used by hosts and routers to communicate some network level information. So this could be error reporting. For example, if a router was not able to reach a host or a network, it can convey to the sending host that it was not able to deliver the packet. Or the receiving host can say things like this port is not valid on my machine, or this particular protocol process is not running on my machine. It can also be used for diagnostic purposes. So the ping that we so often use is part of the ICMP protocol. Routers can also use this protocol for source quench. What do I mean by this? If a source is sending too much data at a higher rate than the router is able to handle, it can potentially send a message to the source saying reduce the rate at which you are sending data. I'm not able to handle it. So here is the ICMP packet format. The ICMP protocol operates at the network layer since it's a companion protocol to IP. But ICMP packets themselves are carried as IP datagrams. So the way you demultiplex these packets at the IP layer is this IP datagram will have this protocol field, which is the demux key. If it is set equal to 1, that means it is saying pass the resulting payload to ICMP. For example, if you have to pass it to TCP, you would have set the demux key equal to 6. So here is the packet format of an ICMP message. It has 8 bytes of header followed by the data. The first 4 bytes carry the type field and the code field. We will look into that shortly. It also carries a checksum that is done over the entire ICMP message. And then following this is the type code defined information. So this will carry some information that will vary based on what the type and the code field is. After this comes the data, and not all ICMP messages will carry data. It's typically carried only in error messages, in which case it will contain the entire IP header and the first 8 bytes of the data of the IP packet that caused the error. Remember that, for example, a router is generating an ICMP message because it received some packet and something went wrong with it. Then it is sending this ICMP message. So as part of this message, it will specify what is the IP header of this packet and the first 8 bytes of data, so that the sender of this packet can relate to what has happened better. So these are the different types of ICMP messages. So there is a type field and code field. I'm only indicating a select ICMP messages. There are a lot more messages. When you do ping, it is of a type 0, code 0. Whenever you browse the web, you may have seen some of these messages that destination network is unreachable or destination host is unreachable. This is arising because of these type of ICMP messages. When we covered fragmentation, I was talking about don't fragment flag. When this flag is set and you have to fragment, the router is going to send type 3 code 4 packet to inform the sender that, see, you sent me a big packet and you said don't fragment, but I have to fragment it. So it will drop the packet, but it is sending this error message back. More type code messages. So the source quench I mentioned earlier. A few other interesting messages. So ping echo request. The earlier echo reply came because of this echo request. When the TTL field expires also, when you're dropping the packet, you can send a source that you have dropped this particular packet. Whether you see a bad IP header, and there are many other information that you can send as part of the ICMP messages. These are not error messages. For example, a host can ask a router for what net mask it should use, in which case the router replies back with this particular reply. So here is a sample ICMP message. So here this is the fragmentation required message, that type 3 code 4. These fields are not used, and since it had to drop the packet because the MTU size exceeded, it is also going to specify what MTU size that particular link corresponding to the router is. And it will also specify, as I mentioned earlier, the IP header and the first 8 bytes of the dropped packet. Let me give an interesting example of the use of ICMP to trace the route of a particular packet. So this is an interesting thing, right? When you send a packet, you will be curious as to what all hops it took, what are the intermediate routers, what is the end-to-end hop count, so on and so forth. This information can be obtained through a trace route command. Again, I will show a demo of this shortly. So what the trace route program does is it sends a series of UDP segments to the destination one after the other. So in other words, it doesn't send the next until it gets a reply for the first one. So the first UDP segment that it sends the TTL value equal to 1. Because it set a TTL value is equal to 1, the first router it is going to encounter will decrement this. It will reach a value of 0 and thereby the router is going to drop the packet, but it won't just drop, it will send an ICMP message back saying that the TTL field has expired, and as part of the ICMP message you can determine what the router information is, what is its IP address, so on and so forth. Then it will send another packet with the TTL value equal to 2, so this will go fine across the first router, but the second router is going to drop this packet and then it will convey to the sender information about itself as part of the ICMP message, and the sender now knows about router 2. So this thing keeps on going till it reaches the particular destination. Once it reaches the destination, you really need to stop this generation of the UDP segments. The way you stop that is by selecting a destination port that is a very unlikely number. In other words, there is no process at the destination that is going to run on this particular port. This is more or less what I have explained. As the nth datagram arrives at the nth router, it will discard the datagram and sends an ICMP message of type 11 code 0, and this includes the name of the router as well as the IP address, and that is how the sending host notes the router information as well as the round trip time it took between the sending host and the particular router. Basically, the time between when it sent the UDP packet till it received the ICMP error message. It will note this time as the round trip time between itself and the router. As mentioned, this packet finally reaches the host, and the host is then going to generate an ICMP message of type 3 code 3 to indicate that this destination port is not valid. That is when the sender stops the generation of the UDP packets. An interesting use of ICMP. To summarize, we studied two useful protocols as part of the network layer. One is the ARP protocol. This is needed when you forward datagrams. This performs IP to MAC address translation. The other is the ICMP protocol. This helps with error reporting as well as host signaling. That's it for now.